Hello, so this is a tutorial on how to input compaction testing, density testing into Questfield. And in this instance, I had to shoot some densities out on Eielson Air Force Base on some electrical conduit inside a trench and the bottom of a manhole. Densities vary kind of wildly as far as locations and what you're doing, but as far as inputting them, it's just good to be consistent, kind of be thorough as far as your descriptions and that sort of thing. So first I've opened up Questfield and I already have my work order listed. Go ahead and confirm it. Open it up. Here's any information I might need. David Ivey is the site superintendent, so I chatted with him in the morning. He was nice enough to give me a copy of the drawings for which I would be doing densities, which is really nice. There are always going to be a set of plans on site. If you're ever confused as to where to go or what needs to happen, just ask somebody. It's pretty easy and straightforward. So in this instance, I submitted this dispatch for myself. I could also go down to do my densities, and I could do new test, new nuclear density down at the bottom. But I already have one here, so just go ahead. Oh, interesting. Anyway, so we'll start here. This is the first one. I'll start from the top, work my way down. Date sample, it was today. The contractor, which was who was actually doing the earthwork, and that was an electrical company. And they are not listed. Anyway, Mass Excavation has been doing all the earthwork out there, so I'll click them for now. Weather conditions, partly cloudy today. It's actually pretty nice. Specification group, field compaction, there's only one option. Specification, which is what kind of compaction do they need. Something like D1 or asphalt would be 98 or 100. In my instance, it was 95. Some other general fills can just be 90. It's an important thing to know before you're going out as far as how much compaction, so you can say whether they pass or not. Moving down, test location. So general location. This is kind of just where you are in the plan set. So in my instance, I was over out at Pond Pump House. So in my instance, I am going to reference the plan sheet, which is EP 106. And the title of that, which was Electrical Site Plan, Pond Pump House. And I'll pull up the sheet in a second so you can see what I'm looking at. Pond Pump House. That way, so whenever these get submitted and whomever's looking at them, be the client, superintendent, or whomever, they can easily reference this based on the plan set drawings. And this changes wildly based on where you're doing compaction testing. So open up the plan set. I just took a photo of it. That's where I pulled that up, Pond Pump House. I put some notes in there as far as where my density tests were along this trench. This isn't a very detailed sheet as far as what was going on. Over here, that's where I pulled EP 106, which was the actual sheet in the plans. So go back over to Questfield. Locations. Now I'm getting specific as to where my density test was. And that was along a trench that was covering up some electrical conduit. And out there along this trail, there were stakes indicating stationing between two major locations. Those major locations were down here on the left, EMH 6207, which is electrical manhole 6207, and the cooling towers VFD control enclosure building, which is just going to be a pump house. And in between, they're running a bunch of wire and that sort of stuff, electrical controls. And they had to excavate it out, throw in the pipe, and then backfill it with some specified fill that they imported, which is what I was doing the compaction testing on. I marked in here the stakes that were out on this little road going out into the pond as far as stationing. So that way when somebody goes back, they can be like, well, that's where he was, that's where the compaction test was. In addition, I had to do the base of this electrical manhole. So there's 3 tests in total. Sometimes you have 12, sometimes you only have 1. Gets interesting. So we'll start with the very first one I took, which was down on the right-hand side by the VFD enclosure building. So I am going to do center of trench. Then I'll do my stationing for now, which was as indicated on the stakes. I could have asked somebody more specifically what that was, but I'm going to do this. And then kind of that line indicating between the two. So I was EMH 6207 / VFD enclosure. Layer type, this was just general fill, nothing interesting. You do have some options in there, especially if you're doing any sort of road work. Oh, utility trench backfill. I'm just going to stick with general fill for now. Depth, this was, so they added about 8 inches of fill and it compacted down to about 6 inches above where they had excavated. And that was approximately 8 inches below the actual grade of the road. So I am going to indicate 8 inches below finished grade or final grade, something like that. You could do FG, final grade. Elevation, this is elevation relative to sea level. And this is really important for most jobs, actually all jobs. But in a lot of instances, you need to ask a surveyor, you need to reference the plan set as to what the exact sea level elevation is. You can do some math based on, like, if they tell you what the bottom is and they're adding so much fill, you can do math in order to figure it out. However, you don't want to be guessing it. You don't want to like pull out your phone and look at the sea level from that. This is like something you want official from a surveyor. And in my instance, I did not have a surveyor on site. I could have asked David Ivey. I doubt he would have known exactly what it was. So in this instance, I am going to leave it blank. However, that's not the case for all density testing and compaction testing, especially in large trenches and that sort of thing, where it is very important where you're doing structural fill, that sort of thing. Moving on to lift number. So this is how many lifts that they were putting in. This, I tested their first lift, one and only, before they do their final grade. So it's lift number 1. Now moving into reference maximum density. This is where I put in the proctor. And if you don't know the proctor ahead of time, you can always open up one of these compaction tests, scroll down to reference maximum density, and this will give you what you need to input into your troxel or nuclear gauge or whatever you're doing, and also tell you what your moisture content should be at that density. So put it and I click it. Now I go down to field density test, which is where I will pick my nuke, which is 79,287. I standardized it that morning, so I will put that in. 273. And the moisture standard, 672. Mode, this was direct transmission because I actually pounded a hole. Depth of the probe, let's see, so for my first one, I did 4 inches. Density test count, moisture test count. The troxler does give this to you at every test that you do, and this is in reference to its standard. I've never inputted those numbers or documented them when I'm doing compaction testing. It's kind of just how the troxler does the math in reference to the proctor in order to give you a result. So I'm going to go ahead and leave that blank. It's just how I have done it. Moving on to wet density, which is what's actually important from the test itself, 147.7 for this test. And it gave me a moisture content of 4.4, which is within the 2% plus or minus for the optimum. So this is a good test. I'm going to hit calculate just because I like that. It'll tell me the dry density. I'll hit calculate again, and it'll actually tell me the relative compaction. Just kind of handy. I don't actually write down the relative compaction into my notes. It's not something that's really important because Questlab's going to just do it for me. And I'm only going to document passing tests unless there is an issue with the material, in which case I will document all of them. But for the most part, all you want to do is input passing tests into Questfield. And then any sort of comments or anything like that could go down in there. I don't have any. And some other tests and stuff, there will be another button down here next to calculate that'll say add new, which is what I was expecting, but there isn't any. So I'm going to go ahead and hit save, and I'll show you how to add another density test. So this is just for one compaction test. Double check everything was correct. I inputted everything, so I've saved it. I'll hit done. And I can go back and edit this if I forget something, like I forgot to input the date or whatever. So now I'll go back down here to new test, nuclear density. And a lot of the stuff auto-filled. As you can see up at the top, it says S2, so this is my second test, whereas the previous one was S1. A lot of the stuff auto-filled, which is great, except for the date, which is really frustrating sometimes, so I have to make sure I start from the top, work my way down. So I don't miss anything, because going back and backtracking, especially if you have like 10 of these and you put in the wrong date for everything or whatever, or the wrong contractor, it's a pain to kind of go back in there. So my general location auto-populated, which is great, unless a couple days, actually day before yesterday, I had to bounce around locations, general locations within the project, and shoot densities, so that was kind of annoying. But in this instance, it is really helpful. So now this is the specific location for my second test, and I try and keep it as consistent as I can. So this will be center, caps, center of trench. If it was a wide trench and say I was, 4 feet off to the left, I would say like 4 feet off center line of trench, that sort of thing. But I was straight in the middle because it's about a 1.5 foot wide trench. Center of trench, 2 plus 75. That's like 200 feet plus 75 or so. And that's in reference to the stakes. I pasted out from the 300-foot stake, and I will do electrical manhole 6207 / VFD closure. Moving down again, it was just layer general fill. The depth was 8 inches below final grade, which was the same because I was on the same lift, but I was just further down the trench. I was trying to get one every 100 feet for about like 250 foot long trench, or 300 feet or so. Lift number, this is still lift number 1. If they had put in a fill and I checked the next fill, then I would change my depth and say I was at final grade. If they put in another one, I would put lift number 2. And again, with the elevation, then I would specify the final grade elevation, but confirming that with a surveyor on site or somebody who can tell me that specifically. Okay, moving down, field density test. My nuke is the same, my standard was the same. I didn't turn it off and turn it back on and have to re-standardize it or whatever. It's not the next day. So that's the same, and it's great that autofills. My probe depth is 4 inches. It's only a 6-inch fill, so I didn't want to punch through the pipe. Density test count, moisture test count, I'm going to leave blank again. 148.3. This was at 4.5%. I'll go ahead and hit calculate. Calculate. You don't always have to just ask to calculate it, but it's nice to confirm your numbers and that sort of thing and make sure everything is a passing test. That looks good. That's what I got. I'll hit save just as I go, as a good habit. Double check everything again. I got it right. I put in the date. Yep. Scroll down. All right, now I can hit add new. So it's great when you're just banging these out if you've got to input like 10 of them or something. So now I'm on to my third and final one. Start from the top, work my way down. Same date. So the general location is going to stay the same. However, I'm no longer in the trench. I'm at the bottom of that, where they're going to put in that manhole, that precast manhole. So I'm going to put in base of EMH 6207. Because, so in this instance, they had to over excavate where they were going to put this manhole and then backfill it with 18 inches of fill. So that's what they wanted me to test out there, just to make sure that when they put the manhole on, the compaction's good and that manhole isn't going to rock around or whatever through frost heave or something or other. Now my depth has changed because I'm not in the trench anymore. That depth was referencing the trench. So for this, I am going to do top of over excavation. And that's what David Ivey told me on site. So this is something that he can understand when he receives these in the report. Top of over excavation, fill. Oops. Yeah, I'm going to go with that. It's kind of generic. Sometimes it's a little speculative as to when you put these things in, but yeah. As long as you can understand it and anybody who goes out there to double check your densities or something like that can go to the plans and figure out where you were and what it was. So again, this was only one lift because they just put in 18 inches of material and compacted it. Compacted a lot of it. It was pretty hard. So still lift number one, same proctor, same material. Moved down to my density test. Probe, I went 6 inches down. Probably could have gone more, but it was really gravelly, not a lot of sand, so it was kind of hard to pound in. It is what it is. Wet density, 148.0. Moisture content was 4%. Calculate. Yep, there you go. Hit save. That's my last one for this report or this density session. Double check everything, date, contractor, all that looks good. Yep, and I'm gonna go down here and hit done. I feel good about all these. I double checked them. If I was uncertain about something and knew I had to go back, I would go ahead and double check that with whomever I needed to, and then I can come back and edit these if I needed to. So these are all good. That's how you input densities into Questfield. Just remember, densities, you're working all over the place. If you're doing a road or whatever, just ask questions. If you need to reference things, look at stakes, ask somebody on site. They're always there to help, and they want to make sure that you're doing good testing. So, yep, so that's it. Go ahead and hit done, and we're good.